Hey guys, I'm Austin, and this is my, what started life as a 2016 Chevy Camaro RC car by Jada Toys. I bought this because I had a 1969 of the same, from the same brand RC car when I was a kid. My dad bought it for me when I was like 12, and it took some abuse, and it ripped pretty well, so I figured I'd buy one and see if I could give it traction control, because I remember it was really hard to make that thing hook up. So I bought this car on Amazon for about $13, and only the yellow one was $13, so that's why it's yellow. But it didn't look quite like this when I bought it. There's been quite a few additions. Originally it didn't have headlights, didn't have this big nasty block of battery sticking out the top. These Hot Wheels stickers were my wife's idea. All these this screen in the back and this heat sink and this knob, none of that was there. These LEDs down here, you can't really see them very well in the tailpipes. Those weren't there. It was basically just your plain Jane RC car. So the way I've accomplished traction control on this thing is I've basically piggybacked off of the original wiring going back to the rear motor, and I've hooked it up to an H-bridge module through the Arduino. So this H-bridge module, which you can actually see here, these vents sticking out of the back, very nicely cut out of the bodywork. And it's powered directly off of a separate power source in the regular Arduino. So there's actually 3 power sources on here. One power source for the RC car originally, another 9-volt battery to run the Arduino, and this big pack of batteries that I thought looked kind of like a big block engine, so I stuck it up on the front. That puts out about 13 volts. This H-bridge is not very efficient, so it cuts that down to about 9. But still, that's way more than the 3 volts that it originally came with. Anyways, there's 2 sensors in here. So one sensor on one of the back wheels and one sensor on the front wheels. It's a Hall effect sensor, and it counts the rotations of the wheel based on these 2 magnets that are on each wheel. So it counts every half rotation of both the front and rear wheels. And if the rear wheels are spinning significantly faster than the front ones, it calculates the percent slippage and uses that to ramp down the pulse width modulation that it's sending to the H-bridge to control the throttle. When I plug in this little 9-volt battery, the Arduino turns on, shows me the rear RPM for the rear wheels, the percent slippage compared to the front wheels, and then I turn on this right here, and that turns on the power to the motors, to the H-bridge. You can also admire my little headlights in the front. So how this works is, when I turn this knob all the way to the left, then traction control is off. If I turn it all the way to the right, traction control is on. And if I click forward on the remote control, you can see that it's cutting throttle, RPM's about 1,000, 100% slip. But if I spin the front wheel with my other hand, you can see the percent slippage is dropping, and it's very rapidly ramping up the speed of the rear wheels. And that works in reverse also. Now if I turn the traction control off, this is only when the traction control is off, it will floor that rear RPM all the way up to like 300, so much that I'm actually worried it might break my RC car. Or 3,000 is what I mean. But it also turns on these little blue boost lights, only for Bruce. So right now traction control is on, and when I floor it, the back tire will spin out just enough that the sensor will pick up a slippage between the back and front tires, and then it'll accelerate slowly from there. Now I'll turn the traction control off, and I'll floor it, and it'll just lose control. Notice my boost flames. So to recap, my user input is this controller that the Arduino interprets and intercepts before it sends a signal to the H-bridge. And I have this knob right here. It's a little potentiometer I use to turn off and on the traction control. Got a user display here, this screen that tells you the RPM and the percent slippage. And I have, of course, the sensors, are the Hall effect sensors that are inside here. And I've got the actuator, which is the motor, which you can't really see, but it's underneath in there. So here are all the materials and tools that I used or had to purchase for this project, totaling me about $85. Went through about 30 batteries, and this whole project is dedicated to my patient wife, who had to endure hours and hours of RC car noises while doing her homework.